Hello everyone, welcome back to my channel. I am Vihan, a perfect AB Precal 5 kid. I took the test when I was in 9th grade and I got a perfect 5. I'm currently in 11th grade and I've started this video series since last year. Now I know that College Board does not give out the official multiple choice practice of AP Precal, and I was one of the first kids to have sat for this test the first time it was introduced. So I know exactly what questions they asked me on my multiple choice. So although I have made these questions on my own, I can guarantee you that these are very much relevant to your test. I have a total of 35 questions with me, and I'll be having them in 5 videos of 7 questions each. So if you like the videos and if you feel that you want to look at all 35 of them, make sure that you watch all 5 videos. Apart from that, the entire 35 question PDF along with the answer key is linked in the description below. If you do choose to directly go to the PDF instead of looking at the video, I would really appreciate if you leave a like or a comment. It would really help me since I'm applying to college as well. Yeah, so let's begin. Question number 22, again a similar type. I want you to be very thorough with these type of multiple choices because these will appear on your AP test. Find all values of x in this domain, again the same domain, that satisfy this equation. You will begin with dividing by square root of 2 on both sides. So sine of x plus pi by 4 is 1 over square root of 2, or equivalently root 2 over 2. Yeah, and when is sine root 2 over 2? Well, it's at pi over 4 and 3 pi over 4. So we have x plus pi by 4 is equal to pi over 4 and 3 pi over 4. Now I have to subtract pi over 4. So x is equal to 0 comma pi over 2. 0 comma pi over 2, option C. The only important thing here is to keep in mind the second solution as well. Don't only keep in mind the first one. So yeah, that was pretty straightforward. Alright, question 23. Which of the following is equivalent to sine square upon 1 plus cos x? I'll let you try. So basically you must be aware of the identity, which is sine square plus cos square is equal to 1. Yeah, so we can rearrange this to be sine square is equal to 1 minus cos square. So this is 1 minus cos square x upon 1 plus cos x, but the numerator is just difference of squares, which is 1 plus cos x into 1 minus cos x over 1 plus cos x. Yeah, and then you cancel this, you're left with 1 minus cos x, which is option A. Okay, question 24 is again slightly an application of the last question, but it is a bit tricky and non-trivial. We have to find an expression for cot t in terms of cot theta in terms of t, where sine theta is equal to t. Now again, the core identity is sine square theta plus cos square theta is equal to 1. Yeah, but sine theta is equal to t. So this is t square plus cos square theta is equal to 1, which implies that cos theta is equal to square root of 1 minus t square. Yeah, now it's simple. Cot theta is simply cos theta over sine theta, but cos theta is square root 1 minus t square and sine theta is t. So this is option C. Alright, question 25, again a relatively easier one. Which of the following is equivalent to 4 times something something something? Yeah, have a shot at it. The only thing you have to do is substitute the value of cos 2 pi over 3 and sine 2 pi over 3. So cos 2 pi over 3, again it's a second quadrant, so x coordinate will be negative. So this is 4 into negative half plus I times, now what is sine 2 pi over 3? It is root 3 over 2 and it is positive, so we have root 3 over 2. You multiply the 4, so you have minus 2 plus I times 2 root 3. So negative 2 positive I to root 3, so option B. Okay, question 26. A complex number satisfies the radius this, the magnitude, and its argument is 5 pi over 4. Which of the following is the rectangular form? Again, it's pretty much the same concept as the last one. You must remember the form r cos theta plus I sin theta, yeah, and r here is alpha square root 2. Then we have cos 5 pi over 4 plus I sin 5 pi over 4, yeah, and then you just simply evaluate it. So we have alpha square root 2. Cos 5 pi over 4 is negative 1 over root 2, negative 1 over root 2, and I sin, so the y coordinate is negative as well, so this is negative 1 over root 2, yeah. Now if I multiply root 2, I have alpha into minus 1 minus I, which is minus alpha I, yeah, minus alpha I, that should be option B. Okay, question 27. I really like this question. In the expansion of x plus y to the power n, the coefficient of this is 10. Which of the following could be a different term from the same expansion? Have a shot at this. Now, many of us might be tempted to work with the coefficient is 10, and the main goal we need is we need to figure out the value of n, right? But let me tell you something. We all know that the sum of powers is equal to n, right? So 2 plus 3 must be equal to 5, whatever the coefficient is. So we know that the expansion that we're talking about is x plus y to the power 5. And according to the binomial expansion, we'll expand it. I have a really good video on binomial expansion. If you'd like to, that'll make the entire thing clear. So this is 5 choose 1 x to the power 4y plus 5 choose 2 x to the power 3y square plus 5 choose 3 x square y cube plus 5 choose 4 x y4 plus 5 choose 5 y5. So this is, if I simplify, this is x to the power 5 plus 5x4y plus 10x cube y square plus 10x square y cube. Again, to reconfirm, 10x square y cube, and the coefficient of x square y cube is 10. So this plus 5xy4 plus y5, yeah. Which of the following could be a different term from the same expansion? Okay, x4y, I have a coefficient of 5. This is not what we're looking for. x4y, again, it has a coefficient of 6. 5x to the power 4y, absolutely, yeah. So our correct answer is option C. Again, the only thing here was observing that 2 plus 3 is 5, which is the power of the expansion. Alright, question 28. I recommend you try it on your own. If you know the formula to cos 2 theta, this is a relatively very easy one. So we know that cos 2 theta is simply 2 cos square theta minus 1, yeah, and we have cos theta, which is minus 5 over 13. So this is 2 times minus 5 over 13 whole square minus 1, which is 50 upon 169 minus 1, which is minus 119 over 169, which is option A.